Got it.
Okay, who's got a question about a homework problem?
So like
Let's go. Something in the homework that you didn't feel you were prepared to do. Jessica.
Well, it's kind of more of a general question, but like on number 21, where you end up having the log of xy to the fourth over yc to the third. So there are two y's. Do we simplify that?
Absolutely. You always want to simplify. So let's go through that because that uses a couple of our properties. So we're looking at number 21. That looks like this. And the first thing you should notice is these coefficients hanging out here in front. What are those coefficients? They are exponents. So this is really the log of xy cubed minus, or fourth, sorry about that, minus the log of yz cubed. Now, this is a subtraction problem. Yesterday we talked about when logarithms are subtracted, it means the numbers themselves have been divided. So you're going to write this as one logarithm. They get squished together as one logarithm. The logarithm of xy to the fourth over yz to the third. The logarithm of this divided by this. It's one logarithm. It isn't log over log. It's one logarithm. And then her question was, should I simplify that? And yeah, we always do. So that this would be x4, y4 over y3, z3. And we can do some canceling then, and we're going to end up with what? The log of
x to the fourth,
x to the fourth y.
Divided by x.
There you go. And that would be your final answer. Okay? So that used two of our properties. That used the exponent property, the power property, and the quotient properties. All right, anybody else find something in the homework that you had a question about? Okay, what I'd like you to do then, because I want to kind of regroup a few things, in your packet there is, I don't know, it's like the fourth page, and it's an old quiz. It says no calc in big letters at the top. It says quiz basic logs exponents. It's in the big packet. It's not in the review sheet packet. It's in the big packet. And it's about the fourth sheet back. It says at the top, no calc in big letters, and it's quiz basic logs exponent. Okay? Everybody find it? All right, let's run through these if we can. A is actually, that's a bad problem. I said simplify. What I really mean is solve. A is an equation. We need to solve it. What would be your strategy on this? How would you solve this? Tell me what x equals. You would say 3 to the 1/3 equals x. And then you could leave your answer that way. There's nothing wrong with it. But if you wanted, you could rewrite 3 to the 1/3 as the cube root of 3. Now you don't have to do that, but sometimes you're more comfortable with radicals than you are with fractional exponents. It makes no difference. Both answers are completely okay. B, what are you going to do with B? You can set it equal to x. That's one strategy. Set it equal to x, and then do the same thing you did up here. What would this one be rewritten? 2 to the x equals 8. Very good. So x equals 3. Now, there's another way to do that problem. That is absolutely fine. So if you like that way, that's the way you should do it. It's absolutely fine. Another way to do that problem, though, anybody think about it a different way? What's 8? So you could think about it as the log base 2 of 2 cubed, and we have a property that tells us the log base 2 of 2 cubed is 3. So it doesn't matter, you're going to get the same answer either way. What about C? You know the answer is root 7. Those of you that are in tune here know the answer is root 7 because we have the log base E. That's what ln is. ln is log base E. So you have the log base E of e to the root 7. So the answer is root 7. Now kids, that's a property that we got to know. Okay, we've talked about it now for a couple different days. We need to know that one. Okay, what are you going to do with D? There's a radical in it. What's the first thing you do? Change the radical. Because there are no radicals in logarithm land. You can't mix radicals and logarithms. So we're going to rewrite this as the log base 8 of what? 8 to the 1/5. And the minute you say that, the log base 8 of 8 to the 1/5, the answer is 1/5. Now, what are you going to do with this one? This is a 1 over. What pops into your head when you see 1 over? Negative exponent. So this is really ln e to the negative 6. Harry, you with me?
Yep.
What's the base on this logarithm right here? E. Log base E of e to the negative 6. What's the answer? Negative 6. Uh-oh, F, that's a property. The log base 9 of 1 is? 0. The log base anything of 1 is 0. Uh-oh, G, a little bit trickier. What are you going to do with G? What's step 1? Gotta be. Move the exponent. You need to move the exponent. So you're going to have the log base 2 of 4 cubed. What's 4 cubed? So you have the log base 2 of 64. Now, you can do this any way you want. What's your thought? Pretend this is your quiz. You're sitting here. Anna Heckman, what are you going to do with that problem? You're going to set it equal to x and rewrite it as 2 to the x equals 64. And then you're going to figure out what power you raise 2 to get 64. Do you know what that is?
6.
Okay, well, let's count. 2 times 2 is 8, 16, 32, 64. So it's 2 to the 6th. So the answer is 6.
Can you like break down the 4th there?
Yep, you could have, right from the beginning, said this is the log base 2 of 2 squared cubed. And 2 squared cubed would be, so the log base 2 of 2 to the 6th is 6. Again, you need to do it the way that makes sense to you. The answer is 6. Somehow get 6. Number 2, does this equation represent growth or decay? We talked about this a few days ago. This is decay. You are multiplying by 0.14. Is your number going to get bigger or smaller if you multiply it by 0.14? Smaller. This is a decay problem, right? What is the rate of growth or decay? Be very, very careful.
1 minus 0.1.
It's 86% decay. It's 86% decay because when I multiply by 0.14, that means my answer is going to be 14% of what I started with, which means I've lost how much? I've lost 86%. Remember, when you multiply, in one of these percentage increase or decrease problems, when you multiply, you're either multiplying by 1 plus the growth or 1 minus the decay. So if you're multiplying by 0.14, you have lost 86%. Does that make sense to you? Okay. What is the initial value in number 2? 18. You know enough about exponential equations. Exponential equations are of the form ab to the x. This is your initial value. Log is the symbol for what?
Base 10.
Base 10. So you would write log base 10. That's what it's a symbol for. Simplify. How would you begin this? There are a couple different ways, so it's not one right answer. How would you personally begin it, Alex O'Malley?
Flip it.
Okay, tell me why you'd flip it.
It's a 1/2.
Oh, whoa, whoa, time out, time out. When do we flip?
Negative.
When it's negative. Okay, now there is a negative in here, so if you wanted to take care of that negative, Alex, you could do that right off the bat, but the only thing that's gonna move is that y to the 10th is gonna come to the bottom. We only flip with negatives. Now, Alex, let's try again. What would you like to do now?
Square root.
Okay, we can do that. That means raise everything to the 1/2 power, including the 9 and the 16. So that would be 3x to the 5/2 over 4x squared y to the 4th, y to the 5th. I take everything to the 1/2 power. Every single item in there to the 1/2 power. Okay, now what do I do?
Combine the lines.
Yeah. So, and the x's. This is 5/2, this is 4/2. Where do I have the leftover x's, on the top or the bottom? How many more on the top? Not one, 1/2. And I got 9 y's on the bottom. Now, personally, I would not have done things in the order Alex did them, but that's okay. As long as we all end up at this spot, that's good. I got a little logarithmic equation down here, and it was a bonus. Let's see if we can figure this out. I think we can. Does anybody have a thought as to how this problem might start? Anna?
Is it log x over 2x?
Exactly, exactly, very good. Here's the deal, groupies. When we are solving logarithmic equations, and we haven't done very much of that yet, but when we are solving logarithmic equations, you can't have more than one logarithm on each side. So if you have 2 logarithms on the same side, you need to put them together exactly like Anna did. Anna said, look, they're subtracted. That means I have a division problem. When logarithms are subtracted, the numbers are divided. You cannot have more than one logarithm on each side. So if there's more than one, you have to figure out a way to put them together. If they are being subtracted, you'll put them together as a division. If they're being added, you'll put them together as a multiplication. Now what? You know.
You multiply 2 plus x.
No. Think about the very first problem we did. Look up at number A. It's really the same kind of problem, you guys. This is bigger and uglier, but they're the same kind of problem. What did you do with this one?
Solved it.
How did you solve it?
4 squared.
Well, this one you said 3 to the 1/3 equals x. So what are we going to say here? 4 to the 2nd equals x over 2 plus x. That's how you solve this logarithmic equation. You got to get rid of this logarithm, and you get rid of it by rewriting it in its exponent form. So 4 to the 2nd equals x over 2 plus x. So that's 16. Now, Anna, how do you want to solve this?
Multiply 2.
Yeah, now we're going to bring that 2 plus x over here, so we'll have what? 32 plus 16x equals x. So 32 equals negative 15x, and x equals negative 32/15. Now we need to talk about this for a second. When I go back to the original problem, that would mean I would be taking the logarithm of a negative number, right? I want you to think about what the logarithmic curve looks like. Looks like this, right? This is the equation y equals log base b of x. Tell me about the x's in this picture, you guys. What do you know about the x's in this picture? They're all bigger than 0, aren't they? Can you put a negative number here? Do you have any negative x's as part of this? This is an extraneous root. Now, a temptation is every time kids do a logarithmic equation, because we make a big deal about it, you can't take the logarithm of a negative number, period. The other night in your homework, there were some exercises done on the calculator. I don't know if you noticed or not. If you did the homework you did, when you put in, they ask you to find the log of negative 1.83 or something. When you put that in, what did the calculator say? Error domain. You can't put in a negative number. You can't take the log of a negative number. Well, sometimes we'll have an equation that'll look like this. Okay, I'm making this totally up, okay, but we've got some equation like this. And the kids go through and they solve it all nice, and they get -2 as an answer. And they immediately throw it out because they say, Miss Ford, you can't take the log of a negative number. But be careful. If I put, this is negative, but am I taking the logarithm of x? No. No, when I put that back in, it's okay, isn't it? So this would not be an extraneous root. You can have negative numbers as your answer as long as when you plug them back into the original, this stays positive. That's what has to be positive. Do you understand what I'm saying? So don't throw it out just because it's negative. You got to plug it back in and make sure. Okay, that wasn't so bad. Let's turn it over. Oh, there's a makeup over there. Let's go through this. I think we can do this pretty quickly. Hey, what do you think the answer is? In fact, let's do this. I'm going to give you 3 minutes at your tables. Answer all of problem number 1. See if you can get all of problem number 1 done in 3 minutes. At your tables. Share answers, help each other, figure out part 1. If you can go farther than that, that would be great.
Let's see.
Is B -4? Yeah.
I got
Since it's 381 equals x, so it's 3 to the x equals 8.
would you for F?
You have to
Saying that you-
Uh,
that's how you said that.
choose it.
Log 3 of 3.
Oh, I forgot to multiply it. Decay.
Okay, do we have part one done? All right, let's,
27.
let's run down through the answers.
That's 17.
Pardon this interruption, this is Ford.
Yes,
Do you have Jessica Weir with you at this time?
I do.
Could she please report to campus ministry?
Oh, shoot, we're in the middle of some logarithm work.
I'm sorry, Mrs. Whitcomb requested her.
Okay,
Thank you.
okay. A, what's the answer? 5th through to 4, or if you prefer, you can just leave it 4 to the 1/5. Okay, B, 2. Now, we're gonna go through all the answers, and if you have a question, you can ask it, but B is 2. What's C? 3/4, very good. What's D? 1/3. What's E? -4. F, +4. And G, 0. Very good.
Can we go over C?
C, what does a 4th root mean, Katie?
The 1 forward.
Yep, so you have ln e cubed to the 1/4. So you have ln e to the 3/4. What's the base on ln? E. So log base e of e to the 3/4 is 3/4. Did anybody get to number 2? Did you get that far?
17%.
That would be growth or decay? Decay, how much? 17%. What would 17% growth look like? 1.17. 1.17 would be 17% growth, right? 1 plus 17? Decay is 1 minus 17. What?
If it was like 1.17, would you put 17% still? Or would
Yes.
you put?
Yeah, you would put 17% growth. Okay, did we get to 3? Probably not. Did anybody get that far? How did you start number 3? If you got that far, what did you do first? Alex O'Malley, here you go. You flip it, and this time he's right. Now, you don't have to flip it first, but if he wanted to flip it, this one he could flip, right? The whole shebang. So 2xy on the top, 3x negative 3y squared, and now it's being cubed. If you're handling this negative exponent, whatever was on the bottom goes to the top, whatever was on the top goes to the bottom. It is a complete flip. Right? Now, Katie Swanton, if we did what Alex wanted and we flipped it first, so now we're here, what would you do next?
I distribute the 3.
Okay, that means take everything in there to the 3rd power, including the 2 and the 3. So 2 cubed is 8, x cubed, y cubed on the top, and then I've got
27.
x to the -9 and y to the 6. Perfect. So assuming this is where we're at, Jadelle, what would you do next?
Put X on the top, right next to the
Take this guy to the top? Okay, so when I do that, I'm going to end up with, I've already got 3 up there. I'm going to bring the 9 up, so I'm going to have 12 up there. While I'm at it, let's take care of these y's. I've got 3 on the top and 6 on the bottom. Who has more? The bottom. How many more? 3. So I got a y cubed on the bottom. Why are you looking at me, Delaney? Is that all right? Okay. And then we got another solve problem. So we've already been through this. Let's see how much you remember. Julia Hinkus. What do you think we should do first with this logarithm problem?
Put like
want to put these two things together. You have to. Kids, this isn't a choice. You can't do a logarithmic equation if there's more than one log on either side. So if you have two, you've got to put them together. These are being added, so exactly like Julia said, we're going to put them together as a multiplication. So she has the log base 3 of 2x plus 8. Now, Emma Veely, what happens next?
3 to the second equals 2x plus 8.
Perfect. So 9 equals 2x plus 8. 1 equals 2x, and it looks like x equals 1/2. Now, I want to caution you again. You can get extraneous roots every time you solve a logarithmic equation. I know that's a positive answer, but it could be extraneous. It isn't. But if this problem had been this, you see how that would be an extraneous root? Because what happens when you put 1/2 up here? This becomes negative, and it can't be. Now, it wasn't. It was a plus, so we're good. But you always got to check whatever answer you get. Make sure when you plug it back in, this stays positive. Okay? All right. So you feel okay about that? Some pieces start to come together. Oh, shoot. Let's look at the next page real quick. I've just got so much good stuff here. Let's look at the next page. It's not headed. It's just a bunch of spare stuff. Let's see. Who hasn't spoken yet today? Mel Bardis. These aren't numbered, but the very first one, we'll call it number 1. What do you think? What would be your first step for that problem?
Bring the negative 3 over.
So how would you write that?
3 to the negative third equals x.
Exactly. Perfect. And what does 3 to the negative third mean, Logan?
1/3.
Well, it means 1 over 3, but don't forget it's cubed, so it wouldn't be 1/3, it would be
1/13.
1/27. This means 1 over 3 cubed. 1 over 3 cubed. Right? 1 over 3 cubed? So the answer is 127. Good. How about the next one? Maria.
X to the second equals 81. So
Exactly. X to the second equals 81. Perfect. Which means x must be 9. Now, I know when you solve this, you might think plus or minus 9, but the base must always be a positive number. So when we write log base x of 81, this has to be positive. So the answer is 9. Beautifully done. Strife, next one. Number 3 there.
You bring the 2 over
So what am I going to write?
x squared equals 81.
Okay, we just did that one.
Oh, jeez.
Wake up and smell the coffee, as my mother would say.
So before, to the 1/2 equals x.
Yes. And what does 4 to the 1/2 mean, Tom?
The square root of 4.
Square root of 4, which is
2.
2. So we would write 2. I want to make that clear. This is not an acceptable answer. I mean, it's a good first step. But 4 to the 1/2 simplifies. If it had been 4 to the 1/3, you could leave it that way, because that's the cube root of 4. But 4 to the 1/2, you need to write 2. Okay, the next one, number 4. What's your thought on that, Redor?
10 to the x equals 100.
Okay, so a couple of things going on. First of all, you're setting it equal to x. And second of all, you're recognizing that the base there is 10. And you're saying 10 to the x equals 100. So the answer to the problem must be 2. Perfect. Did everybody catch all that? Mackenzie, next one.
4 to the x equals 16.
Perfect. 4 to the x equals 16, so the answer must be 2. Bingo. Deanna, next one.
to the 1/3 equals x, and x equals 1/3.
Exactly. So you can either just recognize the base here as 1/3 and say, okay, that equals 1/3, or you can rewrite it as e to the x equals e to the 1/3. Either way, the answer is, as you said, 1/3. Very, very good. Number 1, down there at the bottom, little quiz there. Number 1. Let's see. Gracie, 4 squared equals x, so x equals 16. Harry Payton, I'm going to come back there and smack you. What's number 2?
That's a good question.
Are you on the right page?
Yes.
Okay.
Yes. You gotta set x cubed equal to 64.
Exactly. So step 1 would be x cubed equals 64. Harry, do you know what cubed is 64? 4. Perfect. Dodged another bullet. Mr. Stark, number 3.
3 to the -2.
So you would start, that's exactly right, 3 to the -2 equals x. And what does 3 to the -2 mean?
1 over 3 to the second.
1 over 3 squared, which is
1 over 9.
1 over 9. Perfect. Number 4, Andrew.
Let me just see the answer.
Well, tell me how you got the answer.
So it's a log base of 10. So 10 to the x to 1,000. So x is 3.
Yep. So you did a couple of things there, just like Redor did a minute ago. First of all, you recognized that the base was 10, set it equal to x, and said 10 to the x equals 1,000, so x equals 3. Perfect. Michael, number 5. 3 to the x equals 81, so x equals 4. Perfect. And Madeline, the last one?
So it'd be 1/2, so
What was your thought process? How'd you?
log e to the e is a 1/2.
Yep, so you knew that had to be 1/2. Perfect. Okay, well, I'm sure there's tons more fun there, but we need to look at a couple of things in our book. Tonight's homework is on the same page as last night. Okay, I'm assuming that logarithm stuff's starting to come together a little bit, those basic fundamentals. Okay, let's look. Number 29, I think 30 and 31 and 32. I'm on page 317 still. Who remembers a brief conversation we had yesterday about using the change of base formula on something like this? Does anybody remember that? Real quick at the end, we talked about we could use a little shortcut. Anybody remember that? Was I talking to myself? Thank you, Delaney. What did I say about this?
That'd be log of 6 divided by log 4.
Exactly. Log 6 over log 4. And I went through this step by step. Now, what you just did, and this will always be the case, but what you did was you took a log base 4 and you rewrote it in terms of base 10. And we actually got our calculators out and noted that if I would have ln, these two answers were the same, right? Remember, we typed them in on our calculator and verified that? So if this is what you wrote down, you took a base 4 and rewrote it as a base e. Now I want you to look at problem 29. It says take the log base 3 of x and rewrite it. Okay, now this is a base 3 logarithm. It says rewrite it using natural logarithms. Now, in other words, change the base but use base E. This will just be ln x over ln 3. That's your change of base formula. It's exactly what we talked about yesterday. Only they're specifying use natural logarithms. So what would number 30 be? What's the log base 7 of x going to be in terms of natural logarithms? ln x over ln 7. That's all there is to it. You're done. Now look at question 33, which is the log base 2 of x. But read the directions to number 33. What are they telling you to do there? Use common logarithms, which means you're going to do exactly the same thing, but it's going to be what? Log x over log 2. Do not make those hard. They're easy. Now, I'm asking you to do some graph matching. Look at 43, 44, 45, 46. I'm asking you to do some matching there. I've assigned some of those, not all of them. But here's the thing. Everybody needs to remember what the basic logarithmic curve looks like. And then you need to remember what happens. Okay, your basic logarithmic curve is this. That's the graph that you're starting with. Now, if I wanted to turn that upside down, what would I have to do? Make it negative. What if I wanted to go this way? Make the x negative. What if I wanted to pick it up? Put a, here's the equation. Put a plus or minus out here. What if I wanted to shift it left and right? Put it like this. So remember all those rules, and then you should be able to match up those equations. Okay? So that's what you're going to do. I'm not going to do those for you. I want you to do those on your own. Then I've given you a couple of word problems to do, and I do not want you to panic with them. Look at 52. I know it's got words in it, but it is not hard at all. They give you an equation that happens to have logarithms in it. And they go through and tell you what all these things stand for. It's all nice and hunky-dory. But then look at question A. I'm looking at 52, problem 52A. What do you think I'm going to do? I'm going to plug all those numbers in. So I have the log of 250 over 2 plus 4.25. Then guess what I'm going to do? After I get everything plugged in, guess what I'm going to do? I'm going to type it in on my calculator. Now, it's an LOG, so I have no problem doing that, right? I'm just going to type it on my calculator, whatever decimal comes out, that's the answer. Nothing hard or tricky about that. Okay? We good? All right. So, that's all I have. I don't have any papers to turn back. I'm good to go. You're good to go. Go ahead and get started on your homework. You've got 2 minutes. We got a lot accomplished today.